All right. It is good to see everybody. I hope that you're having a good day and that you had yourself a good weekend. So we are now in the second 9 weeks. We're going to go ahead and start chi-squared test for independence today after we answer some questions on the t-test, because remember, tomorrow that's when we have our quiz over the t-test. Everything got shifted ahead because of the Texas Tech EE trip last Friday, was it? Okay. So we'll go ahead and just pick up. So that's going to be the majority of our week after the quiz tomorrow. We're just talking about chi-squared test for independence. As of right now, I have, I'd have to check my next week. I'm going to post that in the next day or so, but I believe I have the homework due on Friday and the quiz next week. I want to say Monday or Tuesday. I don't want to go ahead and say until I'm absolutely sure. But hopefully by the end of the week, we're able to start the next lesson. And if not, we'll carry it over to next week. Yeah, it works out too. But the only other thing I want to let you know, what's happening on Wednesday. Okay, so that's goals day. So it's not only a late start day, but it's a half day. You're going to be getting out at 12:40. So if anybody was interested in the schedule, I did go ahead and post it to our current week right here. So it looks like the classes 1 through 4 are going to be just under an hour, but I won't see you on Wednesday. So I'll see you tomorrow for the quiz. We'll continue chi-squared, and then I'll see you on Thursday, and we'll kind of see. So because of this Wednesday, that kind of throws a monkey wrench into everything. We may or may not be able to finish up with chi-squared so the homework can be due on Friday. So if I have to push that forward, I'll definitely let you know, and we'll go from there. Don't forget that on October 28th, a week from this coming Friday, that's when your outline is due. So I did go ahead and pass out those documents last time. I've got extra copies if anybody needs one. But in order to receive full credit on this, I do need to see data. Now, remember, this is just like almost like a progress check. If you decide to change your topic or you decide that this data isn't good, as you move on down the road, that's perfectly fine. This isn't set in stone. I just want to kind of gauge your progress as we're going through this. All right. Yes. I would. Yes, please. Okay. And then also, if you're collecting it yourself, like if you have a survey, or just give me a small little explanation of how you collected the data. Okay. All right. But are there any questions? Yeah. All right. What do you say we go ahead and get started? We talked about the t-test the last time I saw you folks, Thursday. Everybody seemed to be doing a little better with those. How do we tell the difference between a one and a two-tailed test? Okay, so two-tailed, we're simply saying in the alternative hypothesis that the means are not the same. But for the alternative hypothesis in a one-tailed test, that's where one is going to be less than or greater than the other. Okay, so if you have an inequality for the alternative hypothesis, that's a one-tailed test. All right. The quiz for that is tomorrow. Yeah, I'm going to give you like a table, give you the scenario, and really it's just writing your sentences, using the keystrokes to go ahead and find the value of P and just comparing it to your significance level. I'm going to have those on the board. Mm-hmm. Yeah, because it's a lot to remember, unfortunately. Yeah. Now, I will go ahead and tell you that when you get to the formula booklet for the paper exams, they don't provide this information. So unfortunately, at the end, you will have to go ahead and try to remember how to compare the two, which I don't really understand. They'll give you everything else, but they won't give you this. I don't know. Check. Oh, so I mean, I can go ahead and also put up there one-tailed and two-tailed. Now, I might have to go ahead and put it on the backboard because I'm going to have information up here for pre-cal classes as well. But I'll probably have this up there as well. Remember, your p-value, if it's greater than your significance level, you accept the null hypothesis, or we say we fail to reject, because the idea, if we went ahead and performed the test at a different significance level, there is the possibility that we could have a different outcome. That's the only reason why they want to have it like fail to reject. But if you go ahead and say accept the null hypothesis, I am definitely not going to count off for that because you're correct. Okay. If the p-value is less than the significance level, then you do not accept the null hypothesis. You'll accept the alternative hypothesis. Okay, so did we just want to go through a problem real quick to kind of review? Because we did a couple of problems. We did one with this oil company, oil's well that ends well. So, oh, slick, nice. Okay, so do we want to go ahead and just take a look at one? Sure. Okay. So this first one here, this was the first problem on your assignment. And if you want to hang on to it today to use that as kind of like a study guide, that's fine. Just turn it in whenever you have the opportunity. Petra noticed that one of her apple trees grew in the shade and the others did not. She wanted to find out whether the apples from the tree in the shade weighed less than those in the sun. Okay, she picked 9 apples from each tree and weighed them in grams. So here's the data. Okay, now remember one thing about the t-test, do you have to have the same number of elements in both sets? You don't have to. That has no bearing on what we're doing, and that's actually okay. So let's go ahead and say the apples from the tree in the shade, that's going to represent the first mean. I should probably put a bar above these. And the second row here, the apples from the tree that is not in the shade, that's going to represent that second set of means. Okay, so what do we always say for the null hypothesis? That the two means are what? The two means are equal. Okay, so the mean of the first is equal to the mean of the second. Now, let me ask you a question. We're going to go ahead and skip right to B. State whether this is a one-tailed or a two-tailed test. Is there anything here that's going to indicate what my my alternative hypothesis should say? There you go. Weighed less than, so we're comparing them using an inequality. If one of the means is going to be less than or greater than the other, this is a one-tailed test. Okay. So if we're simply saying that the two means are not equal for the alternative, that's a two-tailed test. Okay. So in this case right here, we're saying that the apples from the tree in the shade, so that would be the mean of the first, is less than the mean of the second. Okay. So now what I want to go ahead and do is just take those ideas for the null and the alternative hypotheses, and I'm just going to want to go ahead and write a sentence. Okay. So give me a sentence that would help me here. Okay, so let me start to write this down. So part A, for the null hypothesis, the mean of the apples, let's say from the shade tree, what? Remember, what are we trying to say here? So is equal, so we could say is equal to, is the same, okay? Is the same as the mean from the tree not in the shade. Tree not in the shade. Okay, and remember, there's a lot of different ways you could paraphrase that. The mean of the apples from the shade tree is equal to the mean from the apples of the shaded tree. So see how you can slightly change it, but you still are conveying the same idea? Okay. All right. Well, let's go ahead and take a look at the alternative hypothesis. So we're going to say the same thing, except what? Yeah. So the mean of the apples from the shade tree is what? Less than the mean from the tree not in the shade. And if you want to go ahead and incorporate the fact that we're weighing this in grams, I mean, any more detail you give, I always think that's going to go over well with the IB graders. Okay, so the mean of the apples from the shade tree is less than the mean of the apples from the tree not in the shade. Does anybody want me to go ahead and write that down, even though I just wrote it? But is everybody okay with those? Okay. So we've got the null and alternative hypotheses. So I'm going to go ahead and I'll do this. Okay. Is less than. So we're going to go ahead and replace this. Okay. And then we'll have those. What are they called in English where you have those marks that tells you the sentence is repeating itself? You know what I'm referring to? Like these little slashes right here that would mean that it's the same thing. They look like quotation marks, but I thought they had a specific name. See, I'm not an English teacher, so I wouldn't know. Okay, all right. Now, find the t-value and the p-value, but this one, we're going to test it at a 10% significance level. So changing it to a decimal, that's 0.1. Okay, so let's go ahead and set this up. I'm going to go ahead and get this ready. So I'm going to go ahead and put my 0.1 right here. I want to compare my p-value to my significance level. Okay, and then my t-value, I'll just go ahead and put over here to the side. Let's go ahead and say 3 sig figs. So I'm going to go ahead, come on over here to my calculator. I actually don't have that paper in front of me. Could someone go ahead and tell me the grams for each of those 2 apples? Oh, thank you. Thank you so much, Nathan. Okay, so I'm going to go to New, List and Spreadsheets. Okay, so we have the first set, we have the second set. Okay, so the first row here is 75, 82, 93, 77, 85, 78, 91, 83, and 92. Okay. Now we're going back up to the top where I have 74, 81, 95, 79, 95, 82, 93, 88, and 90. Okay. There you go, sir. Thank you very much. Okay, so I've got my data in. Okay, what are my keystrokes here? Okay, so I'm going to go to menu. Okay, so we want statistics, stat tests. Okay, so that's a good way to remember it, 444. Okay, 2-sample t-test. So this is going to use the data we put in, okay? Now the first 2 lists, those are your first 2 columns that we input. So the first one is the first column X, the second one is the column Y. Don't worry about the frequency. Now we are going to have to make a change here because this is a one-tailed test. Remember, we were saying that the mean of the first one is less than the mean of the second. So we want to go ahead and put in the appropriate alternative hypothesis. For pooled, we always put what? Yes. Again, I don't know why. What that means is that pooled is that we believe that the standard deviation for each set is the same. But I don't believe we could always say that. So I'd really like to know the reason why IB. But anyways, I'm kind of going off on a tangent here. Anyways, everything's going to show up in column D. Let's see what we got. You know, in the last class, I was kind of embarrassed because my tan line was showing. I was teaching them how to graph tangent, and they were not liking it, okay? They were not liking it at all. All right. So let's see here. For the t-value, what would that be for 3 sig figs? That's right, negative 1.20. Remember, that 0 would be considered a placeholder. So negative 1.20, and I come over here. That is not what I needed. Oh, yeah, we're still on the first one. That's the t-value. So I'm going to come back over here. Let me go ahead and show you that. So here it says negative 1.19925, so we just rounded it to 3 sig figs. Sure. So you've got negative 0.6872. Huh. Here, did you just recently do this? Okay, try this one again. Go ahead and run through the keystrokes on that, and then we'll see if you end up with the same thing. If you do, I'll see if I can help you figure out where we went wrong, or maybe, I don't think, let me double check what I got on mine, because maybe I did something wrong. Let's see here. I know what you're thinking, Mr. West, how could you do something wrong? Let's see. Okay. No, wait a minute. See, on mine, yeah, look, I got negative 0.687. And then the p-value I got is 0.251. Did I put the values in wrong? I didn't think I did. I wonder if maybe I put in the wrong, no? Because, okay, the way we set it up, we're going to go ahead and say that the first mean is less than the other. That's what I've got here. In fact, my alternative hypothesis, I put there is a difference in the weights of the apples from shade weighing less. It's a one-tailed test. Okay, hang on. Let me do this. Did you folks get the same thing or something different? Jack, did you get the same thing or something different? You know what? Let me try this again. Control W. Do you want to save? No, I don't. Okay, so bear with me. Lists and spreadsheets. X, Y. Okay, so the first column here, this is the trees that are in the shade. Okay, thank you very much. So these are the trees in the shade. Find out whether the apples from the tree in the shade weighed less than those in the sun. So this is correct. This is what I have on my paper. So x sub 1 less than x sub 2. Okay, so let's plug this in. So I have 75, 82, 93, 77, 85, 78, 91, 83, and 92. And that should be 9 apples. Okay, so now let's go back up to the top. 74, 81, okay, 95, 79, 95, 82, 93, 88, and 90. Okay. All right. So I've got all my values in. Okay, so menu, statistics, stat tests, 2 sample t-test. I did choose that last time, didn't I? Okay. 2 sample t-test. I'm going to click OK. Okay, so list 1, those are the apples that are in the shade. These are the apples that are not in the shade. Okay, so we're going to go ahead and say that the first mean is less than the second. We're going to pool it. Everything should appear in D. I must have typed in the keystrokes wrong or something. No, I could have sworn I talked about the alternative, right? In the drop-down menu? Maybe I accidentally didn't. Okay, maybe that's it. I remember talking about it, but maybe I mentioned it. I didn't change it. Okay, so thank you for bringing that up. Okay, so let's see here. So my t-value, let's say negative 0.687. Okay, so let's come on down here. La, 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 la. So negative 0.687. Okay, now I know why 7's afraid of 6, because 687. 687. 7's afraid of 6. Oh, okay, you good. And then my p-value, let's see if this matches up. On my paper, I've got 0.251. There we go, 0.251. Okay, so this matches up. Yeah, I'm willing to bet if I go back and look at the video that while I showed it, I just kept them as not equal. I'll bet that's what I did. Okay, so my p-value is 0.251. So which one is bigger? The p-value or the significance level? So the p-value, 0.2 versus the 0.1, so that's a larger value. Okay, so what we're going to do is come back over here. I know that my p-value is greater than the significance level, so we're going to accept the null hypothesis. Okay, so that also means we fail to reject the null hypothesis. So let's come on back over here. Okay, so we accept the null hypothesis, or we say we fail to reject.
Why do we say we fail to reject?
Well, see, we have different significance levels that we could run the test at. If you go back and look at the examples over the notes, we were always running it at a 5% significance level. The three main types are a 1%, a 5%, and a 10%. So the idea is we'll say we'll fail to reject the null hypothesis technically instead of saying accept the null hypothesis, because here we ran it at a 10% level. What if we ran the same test at a 5% level? Would there be a difference? Would that give me a different outcome? So that's the way IB kind of takes a look at that, or statisticians in general, based on my conversations with Mr. Reeves. But here's the thing. If you go ahead, say on the quiz tomorrow, get this, if you go ahead and say we accept the null hypothesis, I'm going to count it right. Okay, because that indicates to me that you know what you're talking about. If you actually want to go ahead and put fail to reject the null hypothesis, perfect. Okay. Now, if this one had been less than, the p-value is less than, then we would reject the null hypothesis and we'd accept the alternative.
So the significance level was 0.5 or was 5%, then we would actually reject the.
Actually, no, we would still accept it.
It would?
Because check it out, 0.251
Oh, 0.0.
compared to 0.05, yes.
So it would go to 0.5.
Mhm,
Oh, you're right.
So in that case, we still would do that, yep. Okay, so how are we doing? What do we think about the t-test? We come up with two hypotheses, and this test tells me basically which one to choose.
So if it had been, if the significance level had been larger than the value, would that mean that we accept the alternative hypothesis?
Yes, we would reject the null and accept the alternative. Do you want me to put that up again real fast? And I think I'll have this on the board at the back. This right here that I have highlighted. So this right here. And actually, we're going to be using something very similar moving on into this next lesson. In fact, the next couple of lessons. How do we feel about the t-test? Feel good? Okay. Fantastic. So we'll come in tomorrow. We'll have a quiz. Remember, I'll have that stuff up on the board for you. Again, I would have it up here. Maybe I can fit it. I don't know. It depends on if I can fit all that, because I have some information for pre-calculus graphing trig functions that I promised them I'd put up there. Okay. And Nathan and Jack, you remember that fun last year, right? Graphing the trig functions? Sine, cosine, tangent. It's been a while. That's okay. Yeah. Cool. Oh, really? We were just looking at tangent today. Oh, so much fun. Really? That wasn't your favorite? Yeah. Oh, yeah. Sine and cosine, really pretty basic. Yeah. Absolutely. Sure. Okay. All right. So let's go ahead and talk about the chi-squared test for independence. All right. So what we're going to be dealing with here are what we call two-way tables, or these are also referred to as a contingency table. Okay. So we have an example of one over here at the right. So basically what it's doing here is it's taking different quantities and it's subdividing them into smaller groups. Okay. Now, this is in no way, my commentary on what is currently going on in our society. So one of these is gender, so they've broken it down into male and female. Okay, so that's just subcategories of gender. I absolutely agree that there's more than one gender. I don't want, anybody to think that I'm, okay. I don't even know why I'm bringing it up. I just want to make sure that, we're good on that. And then you'll know with pattern of exercise, we have exercise regularly and not exercising regularly. So really the data that's collected is right here. Okay, so for example, there's 110 males who exercise regularly. There's 98 females who also exercise regularly. And then you'll notice the last row is the sum of each of these columns right here. 110 plus 98 gives me 208. 106 plus 86 gives me 192, but we also have row totals. How many males were involved in the study? Okay. Oh, not 208. 216. There we go, because you want to look at the rows and the columns, and then we intersect to look at specific information. So how many females were involved in the survey? 184. Now, this cell in the bottom right, 208 plus 192 will give me 400. 216 plus 184 will give me 400. That value in the bottom right corner, that is the total number of participants or items you have in your particular sample. Okay, so this is how it works. Now, we may be interested in how the variables gender and regular exercise are related. The variables may be dependent. For example, females may be more likely to exercise regularly than males. Alternatively, the variables may be independent, which means the gender of a person has no effect on whether they exercise regularly. The chi-squared or chi-squared test, here's our notation right here. It looks like a fancy X, okay, with a squared. The chi-squared test is used to determine whether two variables from the same sample are independent. So here's what it really boils down to. This is the main idea of the chi-squared test. You're still going to go ahead and create a null hypothesis, and you're also going to create an alternative hypothesis. Then, based on the results of your test, your analysis, you're going to choose which one of those is correct. Okay? So we're comparing two quantities. The chi-squared test is simply going to tell me or indicate that, yes, there is a relationship between the two. That means there's a dependent relationship. One quantity in somehow or some way influences the other. Okay? Or they're going to say that the two quantities are independent. There is no relationship between them at all. One doesn't influence the other. Okay? Now, here's the drawback to this. While the test is going to help you indicate that, yes, there's some kind of relationship that exists, it doesn't tell you what the nature of that relationship is. It just says there's a relationship there, and then it would be up to you to go ahead and interpret what you believe that relationship is going to be. Does that kind of make sense? And this is going to be a little more concrete once we go ahead and start getting into some examples. Okay. Well, let's take a look at this next slide here. So calculating chi-squared. To test whether gender and regular exercise are independent, we first consider only the sum values of the contingency table. Okay, we then calculate the values we would expect to obtain if the variables were independent. So if you're working on the paper exam and they go ahead and decide to give you a chi-squared test for independence problem, odds are very good they're going to ask you about expected values. So let me explain what that means. If you go back to your original data here, what I went ahead and highlighted in this blue box, that's the observed data. This has meant that someone actually went someplace and observed these number of males, these number of females exercising regularly or not regularly. And that's how they got their data. The original data is what we call observed. Now, the expected values, these are what we would expect to get if there was no relationship between the two quantities. So if gender and regular exercise have no bearing on each other, what would you expect to have seen at this particular place, wherever the data was collected from? Okay, so what you're going to do is take the column total, okay, times the row total, and then you're going to divide by the grand total of all the participants. Okay.
We looked at this in biology last year.
Oh, did you?
Yes.
Oh, very cool.
And I bet, I mean, it's a great picture. I bet you're going to explain it like 10 times better than
Okay. Let's say now, no pressure, right? So let's say I want the expected values for males who exercise regularly. Okay. Well, I want to go ahead and find the intersection of the column total and the row total that would give me that particular cell. So see, the column total for this cell would be 208, right? What's the row total for that cell? 216. So what I'm going to go ahead and do is take 208 times 216, and then I'm going to go ahead and divide that by 400. That's what I would expect to see if there was no relationship between these two quantities. Okay, so let me go ahead and grab my notes right here. La, 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 la. They're always at the bottom. Okay. Okay, so let's go over to the calculator. I need 208 times 216. Okay, let me go ahead and get rid of all this. Control W, don't need that anymore. So control divide, so 208 times 216, and then we're dividing that by 400. Okay, so control enter. Let's say 112.32. Okay, so that's the expected value of men who would exercise regularly if there's no relationship between gender and amount of exercise. So 112.32. Okay, let me come back over here. So 112.32. Okay, now we just need to go ahead and perform the same operation when it comes to the three other cells. So I know what you're saying. Okay, here's the thing on that. We know that it's not reasonable to go ahead and count, a portion of a person, but IB does want to go ahead and see those specific numbers. Especially if it's less than one particular value, you have to use what's called the Yates correction. But I'm getting a little ahead of myself. Okay, so I know what you mean. Yeah, torso just running on a treadmill. Okay. All right, so I want to go ahead and figure out the expected number of females who regularly exercise. So for this cell right here, I'm going to go ahead and take that column total. What's the row total for the females? See, it's 184. See, both of those would intersect in this particular cell. So I'm going to go ahead and take 208 times 184, and then you always divide by the total number in your sample. Okay, so 208 times 184, let's come on over here. 208 times 184 divided by 400. So I'm going to control enter. Whoa, that is not what I needed. Okay, let's do this as one whole thing. What are the numbers again? 208 and 184. So 208 times 184 divided by 400. Okay, control enter. I'm getting 95.68. Is that what everybody else is getting? Okay. So let's go ahead and try this. I'm going to put 95.68. All right. Try to find the expected value of males who don't exercise regularly, and then the expected number of females who don't exercise regularly as well.
This is my kind of math. Basic addition, or basic multiplication and division.
Love it. Remember, the original data is what we call the observed. This is what we would expect to see if there was no relationship between the groups, or as they might say, independent.
What would you call that? Expected?
Expected values, yes. These are the expected values that we're finding. Let me go ahead and highlight that. No. Now, you might go ahead and round them, but in my experience, I've found that IB wants you to give the exact decimal. Even though reasonably in the real world, we wouldn't do that with this. Okay, with people, you'd have a whole number count. Okay. Okay, has anybody found the expected value for the number of males who don't exercise regularly? 103.68, perfect. So I got that by taking 192 times 216, dividing it by 400. Perfect. What are we getting for this last one? The expected number of females who don't exercise regularly. I got 88.32. I found that by taking 192, that column total, times 184, that row total, divided by 400. There you go. That's how you find the expected values. And a lot of times, they'll just go ahead and give you a particular quantity intersection that they want you to find because they just want to see if you understand that idea. Okay? So now, we're going to go ahead and take the original observed data and we're going to go ahead and start to manipulate it with this expected data. And then what we do in the process, this is the chi-squared test for independence. Okay, so you'll notice here, this is already laid out for us. We found the exact values that we did on the previous slide. So here is the formula. Okay, now F naught, that F sub 0 right there, that's the observed frequency. Remember, the observed frequency is the original data. The data that you first find in your contingency or two-way table. F sub E, that's the expected frequency. Those are the expected values that we just found. Okay. Now, we're going to go through this kind of easy in the first place. If the variables are independent, let me go ahead and highlight these here. If the variables are independent, then the observed and expected values will be very similar. Okay, that is, chi-squared is going to be very small. Okay. If they are not independent, meaning if they are dependent, there's some kind of relationship between the two of them, then chi-squared calculated is going to be large. Okay, so let's go ahead and run through how we go ahead and determine what we do. Remember, here's my formula, right? So we've seen it before. We're going to go ahead and set up a table where every column is another portion of what we need. We need to take the sum total of the difference between the observed and the expected squared divided by the expected. Okay. So you'll notice this right here, it's progressive until we get to the last column where we have F naught minus FE squared divided by F sub E. So for this one, I figured I would just go ahead and have those filled in. Okay, so you'll notice here's my original data, 110, 106, 98, and 86. Now here's the only thing you got to be careful of. I can put the data in any order into this table that I want, but I want to make sure that each original observed data matches with its expected frequency value. So what that means is, if I were to come back over here, you'll notice how right up here up top, the observed values for males who regularly exercise were 110. So what was the expected value for males who regularly exercise? 112.32. So they would have to be on the same row. You want to put the observed data right next to its expected data. Okay. So if you go back and double check that, you'll notice I've already done that. Okay, we'll take a look. The next one, we have to subtract the 2. So for example, 110 minus 112.32 gave me negative 2.32. And the same for the next few rows. Okay, well then I want to go ahead and square it. Okay, add the difference squared. So negative 2.32 squared gave me 5.3824. And then I want to take this value right here, okay, the squared difference between the observed and the expected frequency, and I want to divide it by this right here. Now over there at the end of that row, I got 0.04792. So let me show you that this is accurate. Let's come on over here. I'm going to take 5.3824. 5.3824. I'm going to go ahead and divide this by 112.32. Okay, so there's the 0.04792 that I have at the end of this column right here. I do the same thing for each row. For every set of observed data and expected data, I want to go through that process. Okay. Now remember your formula here. Once I have all of this right here, which is my last column, what's this symbol telling me to do? That's where, that's the sum. That's our capital sigma. That tells you that we want to take the sum of all those values. That's our summation notation in statistics. So if I go ahead and take the 0.04792 plus 0.51914 plus 0.0563 plus 0.0609, that's going to give me this right here. This is my chi-squared value. Okay. Now, how do we go ahead and tell whether yes, there's a relationship or no, there's not a relationship? Remember, we use the words independent and dependent. Independent, no relationship. Dependent, there is a relationship. Again, we just don't know what it is. If you come back over here, would you say the 0.217 is that a very small or a very large value? That's a very small number, right? Ah, that's the thing. Okay, I'm glad you asked that. At what point do I go ahead and say that a number is no longer small enough? When do I go from a small to a large? You're absolutely right. So the first day here, all we're going to be looking at, because we would consider that 0.217 to be a very small number, we'll go ahead and say that gender and exercise activity are independent. Okay, so we'll say there's no relationship between the two. But here's the thing, the significance level. We tested at a 1%, 5%, and a 10%. We take our chi-squared calculated value, and we're going to go ahead and compare it to what we call the chi-squared critical value. So I'm getting a little ahead of myself, but there is a value that you're going to compare your number to.
So you compare the sum to the significance value?
Not the significance, but the significance is part of it. So there's 2 extra steps here that we didn't have in the t-test. Okay.
All right.
I'm just getting a little ahead of myself. So all we need to know for this first day, there is a number that we're going to compare it to. We're just not there yet.
So if it was, say, like 1, would it be large or small?
I would still probably lean towards small on that. Yeah, it also depends on your data.
It's like it depends on the amount of
Mhm.
variables, or not variables, like the amount of observed times.
What we're going to do now, this sum right here, this is the first time you've ever seen chi-squared. So this right here is our chi-squared value. Okay, so this is my chi-squared calculated value. This is what we calculated. Now this is one of those things where if you choose to go ahead and use the chi-squared test for independence on your project, you would have to, like correlation, show how you came up with that value. You can still go ahead and use technology, but you want to walk the reader through everything you did. So what we're going to be doing is comparing the chi-squared calculated value we get to what's known as the chi-squared critical value. Now the critical value is going to be found using 2 things. One of them is called the degrees of freedom, and then we also want to use the significance level. Okay, so I feel I'm talking about it right now is just confusing folks a little more. So not there yet.
All right, but
We'll absolutely get there tomorrow.
all right.
Okay. So let's see how we're doing. Oh, we got 4 minutes. Dang. Okay, so I'll tell you what. Next up, we'll practice some more expected, but we'll use that tomorrow as kind of a review and hopefully help the ladies out if they're here. Okay, so let's go ahead and stop there for now.